In this video, we're going to deduce the structure of the unknown molecule C5H10O. Okay, we've got the NMR here, and we've got C5H10O as our molecular formula, and therefore we should start to think, what do we have? Alcohol, aldehyde maybe, ketone. Okay, so let's look at the alcohol first. We're looking for a singlet with a 1 by it. There's no singlets with 1 by it, okay, so therefore it's not an alcohol. We then look at the aldehyde. Well, the aldehyde comes out between 9 and 10, and you can see there is a peak between 9 and 10. Not only that, it is a triplet. So if you do your n+1 rule, a triplet means it's surrounded or connected to a carbon with 2 hydrogens on it. Okay, if that means that this is a CHO, an aldehyde, which is connected to a CH2. So we've got a CH2-CHO group already. Then we've got a CH2, a CH, and a 6 by it, which means I've got 2 CH3s. 2 CH3s, a CH, and a CH2. Let's go through the peak splitting and think about it. So, we've got this 6 first of all, and it's a doublet. Well, that means it's connected to a carbon, or 2 CH3s connected to a carbon with 1 hydrogen on it, using your n+1 rule. Okay, so therefore that means these two CH3s are connected to this CH. And then this is a triplet, which means it is connected, okay, so it is connected to something that has 2 hydrogens on it, okay? So 2 hydrogens. Well, that's a more difficult one, and we'll come to that as we go through. But let's do our table like we normally do. Let's do our chemical shifts, peak splitting, and our relative peak area. Let's do our hydrogen environments, 4, because of 4 peaks. Okay, and we know we've got a nonette in there, which we didn't really discuss. Now, let's go back to that nonette. The nonette means that you've got 9 peaks, and 9 minus 1 equals n is 8, so that means 8 hydrogens on the adjacent carbons. So if you think about it, this is a CH, and this CH must be next to 2 carbons which have 8 hydrogens on. Well, 6 plus 2 is 8, so the hydrogen on this carbon is bonded to the carbon with 2 hydrogens on and the carbons with 6 hydrogens on. So basically this CH is in the middle of these 2 CH3 groups and this CH2. And we'll start to put that together in a moment. But let's go through the type of protons. So you've got the CH3s, which we thought there were 2 of. We've got a CH where we've got a nonette. We've got a CH2 where we've got our relative peak area of 2, and we've got our aldehyde. We want to make sure we've used all of our atoms, so we take them away from our molecular mass. We find out we've got no atoms left. So we just have to rearrange all of this in a compound, in a molecule that looks correct. So let's put that over to the side and start drawing the actual structure. Let's start with the aldehyde itself. So the aldehyde is that. We know the aldehyde is a triplet, as we said, and the triplet means that it's next, because the n+1 rule, it is next to a carbon with 2 hydrogens on. So basically, it's next to a CH2. So we've got that group because we have looked at this peak, and we have therefore looked at this peak as well, because there's only one CH2, so they must be together. Now we're left with a CH, and we know that the CH3s here, because there's 2 CH3s, they're a doublet, they're next to, if they're a doublet, they're next to a carbon with 1 hydrogen on. Here's a carbon with 1 hydrogen on, so that means my CH3s are bonded to that carbon. So I've got that group, and I've got this group, okay, and it's logical because we've used up all the carbons and hydrogens just to put that together. But let's go through it and check that we've got the right one. So first of all, these 2 sets of hydrogen would be equivalent. That's because they're both bonded to a CH, which is then bonded to a CH2, which is then bonded to an aldehyde. So they are equivalent. Which means, because they're next to a carbon with 1 hydrogen on, you would get n+1, so 1 plus 1 is a doublet. Okay, with a relative peak area of 6. We then go for this one here. Okay. Now that is next to 3, 6, and 2 more hydrogens here, 7, 8. So it's next to 8 hydrogens. Because it's next to 8 hydrogens, Okay, it's n plus 1. 8 plus 1 is 9, so we're going to get a non-net. And that is our non-net, so we've now found out definitely that's our non-net, that works out. Okay, the non-net with a relative peak area of 1, which is as we've got up there. We then carry on, and we look at this CH2 here. Well, this CH2, relative peak area of 2, is next to that carbon with 1 hydrogen on, that carbon 1 hydrogen, that's 2 hydrogens on the adjacent carbon. If it's 2 hydrogens on the adjacent carbon, we're going to get a triplet, because that n plus 1 are on. And then we have this H, which is next to a carbon with 2 hydrogens on. So again, I'm going to get my triplet, this with a relative peak area of 1, which means that we have actually used up absolutely everything, okay, and it fits all of that peak splitting and all that relative peak area to give you this rather nice aldehyde. So to summarise, we have looked for that 9 to 10 peak for an aldehyde. We found a triplet. Triplet means it's connected to a CH2. But if you find that there's an aldehyde and it's a doublet, that CHO is connected to a CH, or a singlet, that means it's connected to a carbon with no hydrogens on. We also looked at the doublet with a relative peak area of 6, which would be 2 CH3 groups around that central carbon with which is a CH. Okay, and that can be very, very common. So they're both really good ones to remember.